those regions around an atom's nucleus where electrons are most likely to be found, right?
Absolutely. And you know what's really interesting? Those simple shapes we learn about, the SPG and f-orbitals, they're just the tip of the iceberg.
Oh, yeah, for sure.
They dictate pretty much everything about how elements behave, how they bond, how they form molecules, the properties of materials, even the colors we see.
Okay, but before we go too far, let's make sure we're all on the same page. We know orbitals, those are spherical. p-Orbitals, those are the dumbbell-shaped ones. And then D and F get even more complex.
Yeah.
But the important thing is that each of those shapes, they represent different energy levels within an atom, right?
Exactly. And as we go to higher energy levels, the number of each type of orbital, that also increases.
Okay.
So like at the first energy level, you've only got one orbital. But then at the second level,
Yeah.
you get one s-orbital, but then three p-orbitals.
Oh, I see. So it's kind of like adding more rooms to a house as you build more floors.
Perfect analogy. And just like you wouldn't just throw furniture into any random room, electrons fill those orbitals in a specific order. It's not random chaos.
Right. They follow the off-ball principle.
Yes.
Always trying to find that lowest energy state, right? Kind of like finding the comfiest spot on the couch.
Exactly.
But I do remember from chemistry class there were some other rules too, right? Like Hund's rule and the Pauli exclusion principle. What do those do in all of this?
Oh, those are crucial. Those are key to understanding how those electrons actually behave within those orbitals.
Okay.
So Hund's rule, that one tells us that electrons, they actually prefer to occupy different orbitals with the same energy before they start doubling up in the same one.
Right.
It's like if you've got multiple comfy chairs, you'd rather have your own space before having to share one, right?
Makes sense. So maximizing personal space even at the atomic level.
Exactly. And then we have the Pauli exclusion principle. And this one says no two electrons in an atom can have the exact same set of four quantum numbers.
Ah, quantum numbers. That's right. It's like each electron's address telling us where it lives within the atom.
It's like an ID card. Yeah.
Right.
Absolutely. So you've got the principal quantum number, M, that tells you the main energy level.
Okay.
Then you've got the angular momentum quantum number, L, that one gives you the shape of the orbital.
Okay.
Then you've got the magnetic quantum number, M, specifies the orientation of that orbital in space. And finally, the spin quantum number, Ms, that indicates the electron's spin.